Hello? Now it's working. Hello, everybody. I'm Casanova, and with Christopher, we work for Igalia, and we have been working several months ago, working on enabling OpenGL applications to work on X server when we don't have enough memory in the GPU to work and use the acceleration. In this talk, we are going to work about how the X server model settings driver, Glamor, and DRI3 are connected to provide us the capability to use GL applications. Then we work. We analyze the issues we have on hardware with limited GPU. It is the case of the devices from Raspberry Pi 1 to 3. We explain the technical approach that we try to work in order to solve that and the current status of this work. So a brief introduction is mainly about what X server to make work. In the past, we need to implement an X server driver and a Mesa driver to have support for applications. But since that we have the model setting driver, if our kernel driver has support for KMS, we have the X server working. So if your GPU has already a GL driver, the Glamor allows us to take advantage of the GL for doing the composition of the pixmaps of the that are used by the windows that we are exposing. So enabling Glamor makes also available the DRI interface to any in the X11 server. But there is an issue here. If our devices are limited by GPU, like the case we have, for example, in the Raspberry Pi 1, 2, and 3, that has a hard limit of 256 megabytes of continuous memory addressing. In that case, we have the problem that is related that if we run out of memory, we could have issues. This is not an issue in the Raspberry Pi 4 because the chipsets included an MMU, so we can access all the whole memory in that. This has been used since the release of Raspberry Pi OS on the Debian full-size version. So since that it was last year at the end of December, our Raspberry Pi 1, 2, 3 are using the model setting driver. But when Glamor is enabled, everything was fine, and at the moment we run out of CPU memory. How we can reproduce that issue? You just open multiple applications, full screen, and one of the applications is good to test. It is just run Chromium. Open several tabs. That is a normal use case, and every window or tab is going to use GPU memory. If you are lucky, and the moment the system, the kernel cannot provide you new GPU memory, the application could crash. Is that this allocation was done by the application. But if you are unlucky, or you're using Glamor, as any, you just launch a new window, there is not available memory for handle that window. The problem is that the X server could crash. And that is not the kind of user experience we want, because the only solution is to restart the X server, or what a user would do is to reboot the system. So one of the solutions is just disable Glamor. But if we have this disabled, we don't have access to the hardware. So the devices previously to Raspberry Pi 4, the decision that was taken was to disable Glamor by default. So at that moment, DRI is not available, so all OpenGL that can be used is software rendering currently. So we were exploring if we can have a DRI3 implementations on the model setting driver that does not require Glamor to be enabled. So it's the work that we have been doing. So Christopher will continue with the technical approach for this work.
Thank you. So basically our goals were to do the X server software rendering for desktop. This way we didn't use any CMA memory on the X side of things. To allow DRA imported exported pix maps using OpenGL or GLES, that was basically the most technical and difficult portion of this. Someone, I think it was you, had found the Nouveau patch where they enabled the DRI3 without Glamor. So for enabling DRI3, there's 4 main functions that you have to implement. It's the screen init, which basically sets up the DRI3 extension calls. The DRI3 open, which opens the device and authorizes its usage, the actual card. Pixmap from FDS to create a pixmap, which wraps a DMA buffer FD, and the FDS from pixmap, which backs an existing pixmap with a DMA buffer. There are a few more DRI3 functions. I did not list them here. The get modifiers, get drawable modifiers, get formats. They're required for our use case, but they're not very technical, so I didn't include them. So the DRI extension implements sharing direct rendering buffers between the clients and the server. Basically, the client will allocate the buffer, and then it gets shared to the X server. This is an improvement over DRI2. It uses a more secure sharing method that uses prime DMA buffs, which are essentially just file descriptors. But we like to fancily name things here. The DRI3 implementation also uses the present extension, which shows the rendered buffers onto the screen, and it handles synchronization with the VBlank. For our particular implementation, we used a GBM to allocate buffers for the pixmap backing. This way, GL applications had something to write into, basically GBM BOs. But when we did that, we did have to negotiate linear modifiers because of using tiled versus linear. So that way they can get composited by the X server. So our current status, the implementation is functional with a VC4, which is RPI 1 through 3, and it's also functional on V3D, which is RPI 4. The desktop does render using software, and the GL applications work using GBM BOs for pixmap mapping. Compositors such as Mutter do work. We did test a couple other compositors. They are functional. I do have to do some more testing with this on an Intel box. Most of the testing was done with Raspberry Pi. However, I did submit the MR upstream for review. It's 945, I believe, is the number. The review actually seems to be stalled at the moment, so if anybody could provide some assistance and take a look at that to see if we can get this actually upstream, that would be great. I don't know what the holdup is, but I guess maybe X is dying and nobody wants to review stuff anymore. Bingo. So now we have some time for some questions and answers. I'm sorry, with this construction, I'm only catching half of this.
So, like with software rendering for like composting, when the Xorg is composting, like, is that something that's really noticeable as slower, or is this like not noticeable that we switch over from like hardware composting to software composting?
It's actually not noticeable at all. Oh, I'm sorry. Yeah, so basically the question boiled down to performance with software rendering on the desktop, and is it noticeable or not? For typical use cases, no, not noticeable at all. Really, I couldn't tell the difference. I mean, I could do some actual measurements and get you some actual numbers, but look and feel and things like that, you didn't notice it at all. No, not a problem.
I can complement, for example, launching an OpenGL application. use case is simpler of using launching GLX. The frame rate using Glamor is around 40, 50 frames per second, and it's reduced to 420 something. It's not really noticeable when you are doing the composition index. The good thing is that it's the current situation. It has always, Xorg has always used in the Raspberry Pi from 1 to 3 the software composition doing by the PixMap framework.
Does this mean that you are running single buffer compositing and kind of copying the GPU frame buffer from accelerated windows into the frame buffer?
Yes, we are doing the bleed at the. We receive the buffer and we bleed it using PixMap. That's the reason of being a linear buffer. So it's done. Another question?
This isn't a question. I'm just very glad that my GPU.
So well. So no other question. Thank you very much.